Okay, now I'm trying to do HackerRank basic problem solving certificate. This is tree thing. I'm not super familiar with it, but let's see. So the directory structure of a system disk partition is represented as a tree. It's n directories. A number from 0, of course, to n-1, where the root directory has the number 0. Start from 0 and keep growing. The structure of the tree is defined by a parent array, the first array here, which is where parent I equals j means that the directory I is a direct subdirectory of j. So if I is j, I think it's probably 0, 1, 2. So this is the index, and the red side is the subdirectory 1. So like this. 1, yeah. So both points with this, something like this. Since the root directory does not have a parent, why? So the which one is a subdirectory? Directory I. Oh, I is subdirectory. Okay, so this is the root. Let's see. The since the root directory does not have a parent, it will be represented as a parent 0 equals to -1. And in this case, this is 0. Why is 1 not? Well, let's just keep reading. The value in file size I denotes the sum of the sizes in kilobytes of the file located in the directory I, but exclude this subdirectory. So you can use the same index to get the size of the directory. The size of the contents of directory is defined as the size of all file contained in the directory plus the sum of the size of the contents of the directory, and this is kilobytes of the file located in the directory. Yeah. So and plus the sum of the size of all its subdirectories. Partition the tree into 2 smaller ones by cutting one branch so that the size of the result subtree are as close as possible. So I think it's probably you are going to like traverse all the nodes and find and build an array and see the best balanced one. Let's see. So example. So -1, and then like 0, 0, and 1, 1, 2. So 1 is this and 2 is this. The structure of the file is shown in the diagram below. Yes, and then like we cut the branch between directory 1 and 0, which means these two. Got this? So one will be, yeah, one is like this, the other is like this. 0, 2, and 5, and 1, 3, and 4. So the so that is yeah, that is how you solve it. So I think you probably want to try to like just loop through. So basically for I inside parent account, and then you try to break it and calculate. The boundary seems to be like within the range of 500, so it's not really a big problem. The only thing here is that if you break, then you need to after you cut the tree, you need to like be able to build 2 trees. And how to do that? So after cutting the tree, the rest is simple. So after cutting the tree, you just loop through each tree and add all the file sizes together. So basically, the core part is to the core part is, I don't think I copy this. The core part is to so let's say we cut it at index. I think the return is the return is the minimal absolute difference. Okay, so yeah, so it's not the I thought it's where you cut it. So basically you decide where to cut it and then build 2 trees and then do the calculation and find the minimum. So this is the hardest part is to cut the tree. So I think it's probably going to be like you cut it at after index 1. So basically it's not from 0, it's from 1, because you cannot cut it from 0. And if you cut, let's say like it's cut between 1 and 0, that means you cut from here. And then how can you get the trees? So you probably from this -1, you try to get everything that's point. So basically 0 point to this because it's 0. So you try to find all the nodes point to this one except for the cut one, and then try to find all the one that is all the nodes that point to this, something like this. And the other thing is that you after the cut, so this will be the root, right? So you try to find all the you go through all the rest nodes, try to find which one is pointing to 1, which will be these 2, and like just add this together. So I think we can build a help. Let me see if we need a helper function on that. So yeah, I think we kind of like maybe have like sum. So sum is from like root. Root will be the like the index, and and then like of course the parent. We can just reuse all the names here, and the files size. By the way, this is like if it's an array, I would prefer to always use the plural form to so that when people see it, it's an array. I think it's like a poorly named. Yeah. And the result, of course, is the sum. So we can rename it as a sum file size, but let's just keep it for now. So for I think the tree is supposed to be in the order, which means if it's in the order, so which means we should not care all the nodes before the root. So which by default is 0, but after the cut it's going to like keep changing. So we will change this to we will loop index. We will loop from like root index. So yeah, again, root is a poor name, so probably we should name it rename it root index. But yeah, let's just keep doing the focus on the algorithm. So root until the end of count. And by the way, there should be a guard that the parent account should be equal to like file size. Otherwise, you should just throw some like whatever customized error. So you should have some sort of like minimum error handling here, and the best the best way is just always to rethrow. But anyway, like this is HackerRank, the edge case are not handled like this. So like it's a difference between the exercise and the real life coding. Just want to point it out. We can do this and then try to get the sum. So we have the sum equals to 0, started from 0, and no, it's not from 0. It should be, well, actually it shouldn't be from the root. It should be from the next one of the root. So which means we should check. So sum equals to the files size, again should be file sizes, would be better. So like we got the sum here, and we guard sum should be like no, I mean the root should not be should be like less than parent there dot count, because if it's only one thing and the root is 0, it's like just a single a single node. So a single node, you cannot really do the loop here. So it should be the root index should be smaller than the count. Otherwise, we just return sum right now without doing this. I mean, we can do this, but it's better to explicitly declare state the edge case. So now we can decide whether a node is the parent thing is part of the. I think we probably need the current node. So current node. We start from root. So if parent index, which will be like we go through this, will be like let's say if the root is 0, and then we start from this. Oh, the one that's been cut should be should be included. So how to say that? So this is root, and this is the so ignored. There should be a single ignored node, and then all the rest will be ignoring that. So ignored, let's add this. I'm trying to think if it's optional, because if it's not, yes, I think it's optional, because there basically could be nothing, or you could pass like something like 0, but actually I don't know. So if it's let's say if we have like ignored as 1, so root is 0, ignored as 1, and then we do the we keep doing this. I think by logic, optional is better. Just say it's not there. So let's just try to start with optional. This is sounds more aligned with the actual business logic. And yeah, let's keep let's keep going. So if the parent index, okay, let's just give it a default value, which is now, sorry, new. And so parent index, the parent index equals to the current node, equals to current node, and it's basically the parent index is not ignored. So this is makes if we go this one, because this is ignored, so we will go to the next one, and then we add we add Sam here. So Sam will be added by the files size. Again, here there should be a guard here. So file size index, and then the question is whether we change current node. We change current node or not. I don't think we should change because there could be another 0 that's pointing to 1, and if in that case net node is going to be calculated, and then I think we probably should have like a known, like a parents nodes array. So like a parent nodes array. So which means current nodes probably is not necessary. So the array should be contain the root node. This really I really want to rename it to index. I think this was better. So it's instead of checking it's a node array, it should be like the parent nodes contains this element, contains the current node. So if this happens, then we will do this, and then like of course the parent nodes will be appended by the new index. So this is one of the valid parents. So keep doing this and keep adding and return some. I think this should work. So next, let me decide where we want to cut the tree. So we are going to actually it should be 0 from 0 because the root is going to be 0, and then we want to you can't really cut at count -1 because you can't cut here. The next is basically not cutting. So instead of that, we are going to loop it to parents count -1, and then we will be like calculating the sum with root index as index, the current index, and the ignored would be like index +1, and then of course we just pass the parents as parents and the file size as file size, again like a port name, but we will keep the interface. And we can get like sum1 and sum2, and basically you know, like sum1 and sum2. The other one is we get from this, and then we don't have any ignored. Well, so which means it's kind of this part is redundant. So let's just remove this for now, and get this, and then we are going to try to get ABI absolute value of S1 and S2. So we are going to like have the sums again plural form. So it's going to be like an integer array. So we're going to append this, or actually no, we just need to get the final sum. So the which is the minimum sum, right? So the the minimum sum. So minimum difference. So meaning let's just try the diff. Not min diff, because we are going to name the difference as min diff as diff, which is the absolute value between sum 1 and sum 2. So we are using the standard Swift library, and it's very easy to implement if it's not there. But it's there on Linux. Pretty sure it's running Linux on the backend. So yeah, and then if so basically it should be like in the max. So that if not max, yeah, max. So if diff is less than min diff, then min diff should be replaced by diff, and then eventually we return the min diff. So there could be some bug, but just like that, let's just run code first and see if okay, so this is wrong. We got 0, and it's obviously not 0. Okay, so we can add some output here. So we can output index, and then if the index and if the and print the diff here and see where we got 0, wrongly got 0. So yeah, when it goes to the second node, we got 0. So by the way, we can get another check. So if diff is no, before this, so if diff equals to 0, then we will return 0, because it's guaranteed to be the minimum 1. So that we don't have to keep going. A little bit of optimization, although we got the wrong number here, and I wonder why we only have, oh yeah, we have, no, why we have three lines. The parent count should be, well, okay, I see. So let's just display the we'll comment out this later, but yeah, let's just display parent and file sizes. So the reason why I'm not creating a a log function is because and use a debug value to control it, is because that is you need to call the function. It will be marked as inline by the compiler internally, but it will still there will be some overhead but to the if check and anything. So for the actually not really. So because it's hard coded and it's debug flag. So actually that may be a better, but yeah, just to try to save time. But yeah, I was wrong. So adding a log function should be better. So now we can see the arrays here. So yeah, we can just keep going this, and yeah, we stop at this. So we probably want to also print sum 1, sum 2. And so what is them? So it's 5 and where are the rests? So diff is 0. Diff is definitely not 0, because we reached to this line. And then where are the rest outputs? Where are the rest outputs? With that fit, oh, because it's already like, yeah, sure. You should print this at this point. It was stupid, sorry. So yeah, we get this, so the I think that if after it's cut, it's going to be 7 and 7, but obviously that's not the case. So let's see which part goes wrong. What the value is and why it could get 7. So here, if we cut at this, so which means the I think it's probably because no, it's -1 is not calculated. So we start from yes. So of course, it should not start from here. It should start from the the start. And if it's from start, so that's you know, like so this only works for the first one. So you have root without ignored, but oh, wait a second. So after you cut this, let's say you start from here. So the ignore will be this. Oh, actually, yes. No, the start should still start from this, and yeah, I was wrong. So the first sum should always start from 0, and second one should start from the index +1, which will be starting from 1 until the until count. Right. So always start from 0. I think this makes more sense. Now we got 1, which is wrong. So again, when we cut like this, it's 8 and 7. So if we cut here, it should be 1 is from this, and then 0 is added to this, so 1, 5, and without this one, and this 2 is pointing to this one, so it should be 5, and now we have 8, which is wrong. And the other one, 7, is correct. So this is correct and this is wrong. This is because when we do the sum calculation, we start from 0, and we have the parent nodes push at 0, and then we move to 1, and because 0 is inside the parent nodes, so it will be like counted as valid, so 4 will be added, and yeah, 4 will be added to sum, and wait a second. So if we still start from 0, it's probably should start from 1, right? I think it should start from 1. Yeah, because the sum is already there. Although this number is not off, it doesn't. I'm a little bit confused. It should be 1. Oh yeah, because -1 there, so it doesn't really matter. But we can start from 1. I think I'm just going to make this small change. I think we should have the same result. Yes, yes, and then we can keep going. So we start from 1, and then the check here is, does it still make sense? Because the root index, it's I'm going to think about this edge case later, but let me just finish this to try to solve the problem here first. So we already got 1, and then it's 2, So when it's 2, oh, the index, okay, so should be index, not parent index. This should be right. So if this is correct, we can run a test and when we think about this check. So the root index should be okay. It's just slower. I mean, this is a problem that so with all my tests. So of course, this code is not optimized. And yeah, this is probably will fail my interview because the reason why they use HackerRank is to evaluate the ability to optimize codes like this. Honestly, front-end development, or actually most API logic backend doesn't matter that much. This kind of optimization usually happens inside the database engine, things like that. But still, it's a skill, and even you don't use it, but it just to know some skills, there's no downside. This is unfortunate, and yeah, it's unfortunate. So let me think about the edge case here. Root index, yeah, you need to beat this, otherwise it doesn't really make much sense to. Well, if let's say, so can we optimize it by check if the ignored is not empty, then we will be. If ignored is not empty, then we will be. Well, let me just submit this first and yeah, finish this two and go back if I want. Unexpected demand. So a widget manufacturer is facing unexpected high demand for its new product. Typo. They would like to satisfy as many customers as possible. Given the number of widgets available and the list of customer orders, what is the maximum number of orders the manufacturer can fulfill? So you have like two inputs. Complete the function on the editor below. No, it's sideways. So yeah. Typo. The function must return a single integer donating the mass and possibly number of fulfilled orders. So field orders have the following parameters. Order. So basically list the order, which is something like this. And the K is the integer donate widget available for shipment. So sample would be like these numbers. So 2, 10, 30. So basically, you try to add all the things together, and when it exceeds, it will fail. So what if it's 3 is available, and then like you input 3, why is not 1? Why is 0? I don't quite get this. Why it's 0? And you need to try to add like 1. So the first, second, you can keep adding this, but or you can skip any of this. Let's say like something like 100, 100, 100, 100. and then you get like 10. So you need to sort it. You need to sort it. Yes. So that sorted orders should be orders again. Is order sorted. So sort the orders, and then you add you just try to see the sum. So basically count, we start from 0, and then for order in sorted orders again. So someone may question like whether like this we want to use this. I think this it can go either way. Like use in this case, so use order sorted here without creating an intermediate variable. It's perfectly fine because this one is very readable. Although it should be, oh no, it's order. So that's why. So like this is poorly named. If it's orders, then for order in orders makes perfect sense. And here, yeah, like a order, an order. Yeah, I hate this. So and we need a sum, of course. So sum equals to an order, I mean itself plus an order, and if some is larger than k, it could be larger or equal to, and depending on how you according to this, it's probably going to be equal to, but I will start it and see if any test fails. So in this case, we will just return count. Otherwise, we still like return count. And the edge case is that it just doesn't go anywhere, we return 0. So like like if k is 1, right? So let's see. This should what? Why? Why? We don't need index. This is simple. So 10. Oh, of course. If so here like if it's larger than k, then we don't increase the count. Yes, this should work. I'm sorry. It's very simple. I will remove the print later. Let's see if we have anything failed. Okay, nothing failed here. So we will change this to whatever. I mean, remove the print, and it should still pass the test. And I will submit. I'll submit this and go back to the first one. Okay, so we modify this. Here, what we can do is to rewrite a function to VC, but the contents thing will be a little bit painful to write. By the way, this is number C. Array contents std function. SD lab. Do we have contents? C++ must have that. Yeah. Okay, so let's just run this again. And to be honest, I kind of want to skip the optimization part. We don't have print anymore, right? So this print can save a little bit time. if we, I mean, we have like so many failed test cases, and if we disable all of them, yeah, 3 of them, so will this be like still 9 failed test cases? Probably yes. Probably yes. Rewrite it, yeah. Rewrite it with C could be could improve the time, but I don't think there's could be a way. There could be a way that if the ignored is not 0, sorry, it's not now, then we have to go through it from beginning. But if the ignored is 0, then there is no point to start from the beginning. Because that is from let's say from this node and onwards. So we can decide this again. No, let's just start another one. So start index should be something like starting. Start index equals to ignored is now. So if it's now, then they should be like start from root index plus 1, I think. Wait a second. So here, no, index already plus 1. So it should be in root index. Otherwise, if the ignored is not nil, then we go through the first one. Actually, no, because the starting point is already included here. So let's just add this to 1. I think this should still be correct. Let's try to run a test and see if more test cases are failing. To see, this will make a little bit faster, but obviously this is not a game changer. It's still too slow for a large amount of the data. And there are 2 things. One is that if it's critical code, performance critical code, you probably don't want to use Swift. I have written a blog myself here. It's just saying that at least in one case, so converting the Swift code direct to C will make you pass the test. Probably the reason is that you like the environment constraint, they all use the standard time limit, which is pretty unfair for Swift, which is supposed to be